Hey guys, welcome back to another episode. It's been a while since I've done one of these Iron Sharpens Iron interviews, but if you guys are used to my channel, you guys know that this series is about bringing you guys coaches, educators, dietitians, everybody, competitors, people around the industry that, for lack of a better term, know their shit. And we try to bring them to you to talk about topics, talk about things that will really help benefit you in your own health, fitness, physique journeys. So today we have a really special guest, Astrid. She is a registered dietitian. And actually, I'll let you just go in and give a little bit of your background.
Oh, well, sure. Thank you so much for having me today. And yeah, my name is Astrid, as you mentioned before. And I obviously come from a background of nutrition dietetics. I've been in the industry of dietitians for about 8 years. And basically, I did my bachelor's degree in South America, completed that in about 6 years, and I did a little bit of educational work and pretty much private practice back then. And then I moved to Australia, did my master's degree here for about 2.5 years. I studied English for a full year, before I actually did my master's degree. And then once I finished my master, I started working as a accredited practicing dietitian in a private hospital. And I've been there for 3 years. And in the meantime, or like parallel to that, I've been working as a coach, nutrition coach.
Excellent. So
that's my story.
She brings a lot of knowledge. She is the anti-diet dietitian on Instagram. So I'll have all her information below for you guys to go make sure you follow her, check out her stuff. She puts out a lot of great information. And we were kind of trying to brainstorm some topics to talk about today. And I think we kind of settled on talking about insulin because, first of all, I think it's a very misunderstood topic. I think that people have been fear-mongered into thinking that insulin is bad. And we just kind of want to give you guys some facts about insulin and just kind of talk about its role in the body, maybe some myths that you might have heard that you don't necessarily need to worry about, things like that, and how insulin isn't as scary as what a lot of people make it out to be. So why don't we start by just explaining what insulin is?
Well, that's a good start of to tell the story. And basically, insulin is a protein. It's a hormone that is secreted by your pancreas. Mm-hmm. And your pancreas is sort of part of your digestive system, but it's also part of the endocrine system. So it has secretion of digestive enzymes in your small bowel. But at the same time, it has an endocrine function where it regulates your blood sugar levels and your metabolism by secreting insulin and glucagon. So it's not just insulin, but it's also glucagon secreted by the pancreas. And these two hormones work as like a seesaw. They don't turn off each other, but they actually are working all the time, but a minute basis to regulate blood sugar levels, to just make sure blood glucose is stable all the time.
Yeah, I like
so
that.
That's what insulin would do. Yeah. So what does insulin do? What's the main role? It is not just to control glucose, but it's one of the main roles that insulin does. So what I will just say is that I give you a very basic explanation of what it does. So when we eat carbohydrates from our normal diet, mm-hmm. basically coming from our pasta, rice, grain cereals, even starchy vegetables like potatoes or pumpkin, or fruit or dairy, anything that contains some form of carbohydrate, that will come in a sort of a complex molecule, right? And this complex or this molecule will go through all your digestive system and will start being broken down from your amylase in your mouth, mm-hmm. and from your saliva, and that starts going to break down a little bit in your stomach, and then most of the digestion of your carbohydrates will be done at your small bowel level.
Okay.
So mainly in the duodenum occurs most of the digestion of your carbohydrates. So once carbohydrate reach the level of the small intestine, your pancreas signals that there is carbohydrates that need to be broken down. So it secretes some specific enzymes, digestive enzymes, that are going to break down the big molecule into very smaller particles that are called glucose, which is the essential or minimal form of monosaccharide that the body can absorb and transport throughout your blood, right?
Gotcha.
So when that happens, what happens is that we get these small particles, the single blood glucose, and that the glucose, and it gets transported and absorbed into the blood, into the blood, right?
Right.
Now, when the body signals that the blood glucose starts rising above normal levels, the pancreas signals that, or senses that that's happening, and that secretes insulin. When insulin is released, insulin is going to work as a key.
Yeah.
Basically, insulin is going to go to the specific target systems or organs that it needs to is going to be using the carbohydrates or the glucose in this case, and it's going to kind of work as the key and the door. So here is the cell, here is the key, and this unlocks all the things that are going to happen behind the scenes within the cell. So if the insulin is working perfectly in a healthy individual, what happens is that insulin is going to unlock the cell, and the cell is going to call some internal transporters to come up to the external part of the cell and kind of allow to open a tunnel that allows the glucose to enter, and it kind of closes the door, and the glucose can enter the cell and then go through the Krebs cycle or whatever is going to happen inside the cell. So basically, that's what insulin does.
It's kind of like a bouncer at a club. It only lets a little bit in, and then it closes the door and shuts everything else off.
Well, that's basically what happens with when we have a case of hyperglycemia.
Right.
So there is a point where it's like we have like a capacity in the room. Like, let's say this is the cell, and there is a certain amount of capacity that it will allow to enter. It's like we have this door closes, then you have the keys for every single door, but the problem is inside the cell, not everyone can enter. So it's too much people, it's going to be overcrowded. So it's the same. It happens with the same with an excess amount of either insulin when we have clients with hyperinsulinemia, or patients with high glycemia, very high glucose levels, or type 2 diabetics. So there's so much glucose that not all of that can enter. So the insulin then says, well, we have a bigger storage. Let's go to that bigger storage, and I have the key for that too. So it brings the excess of glucose to your fat storage, and it allows the glucose to be stored inside the cell in a form of adipose tissue. So it transforms, or it sort of converts the glucose into glycerol, and glycerol is pretty much the basic structure to create triglycerides. So the glycerol is a 3-carbon molecule that can connect 3 extra fatty acids, and that creates a triglyceride. So triglyceride is the form of your body to store fat in the adipose cells.
Right.
Does that make sense?
Yes. Well, it makes sense to me. I think you did a really good job of explaining it to the viewers who might not understand it. I liked all the little analogies used with the door and the seesaw and all that. I think those sort of things really, really help people get a picture, because this can all be very confusing. I mean, I'm sure same with you. When I started studying it, I was like what? This is kind of confusing. But as you start kind of learning how to make these analogies, it really makes things clear. Now, you said you were kind of starting to touch on something that I think is important to understand, that our cells, our muscle cells, skeletal muscle cells, they can only hold so much glucose, right? Before then it goes to the liver storage, and then it starts going over into fat storage. What is about that range? I've seen different things between maybe 300 to 400 grams, and then another 100 grams in the liver. I've seen between 400 and 500 grams. And obviously I think that's going to depend on the size of the person, right? And the amount of muscle that they have in their body. But is that kind of the range, and maybe that 300 to 400 grams?
So I guess I forgot, I would need to explain first, sort of the main target organs that will sort of use mostly glucose. Basically, when you absorb your carbohydrates in the form of glucose, this is obviously going through all your body. It's going to go to your brain cells, to your red cells that are going to primarily live on glucose. Is going to go to liver, to fat storage, and to muscle and other cells of your body. So if we just concentrate on the main three, will be your liver, your adipose tissue, and your muscle,
right? And
your skeletal muscle. So these three are going to basically use glucose straight away if it is needed. Part of that is going to be used straight away as energy, and part of that, if is probably an excessive amount of carbohydrate in one meal, let's say it just surpasses the amount that is needed to produce energy at that point in time, it is going to be taken and resynthesized as the way that the body stores carbohydrates, which is in the form of glycogen. So glycogen is the form that we store carbohydrates or sugar, and the starch is the form of how glucose is stored in your food. So vegetables, plants, they have the storage of carbohydrates in form of starch. So we are similar or alike to plants in that sense, that we store carbohydrates in a form that is very condensed of glucose, but the difference is that is just the structure is going to be a little bit different.
Yeah. Okay.
In the molecular form, but glycogen is the way we store our glucose, and it is pretty much, if you imagine, let me just kind of explain some like how can I see it. When starch can be stored in a form of, like, if you looked at a tree and these different branches, this is similar to how the starch is stored in a cell in a plant.
Okay.
When we look at how it's stored in our muscles, is glycogen seems to be like I don't know, it's like a chain, all mixed up, but it's like compacted and circular. So where am I getting with this? Because I think I'm just flying around with this. It's basically just to say that we can have a limited amount of storage of glucose in our body, and obviously there is a little difference between the storage of the glycogen in our liver versus the glycogen stored in muscles.
Right.
Why? Because muscles are a little bit stingy and selfish. They only use their glucose and the glycogen for their own use. They want, like, if you're dying of starvation and you have no carbohydrates, or you're fasting, your muscles are not going to give anything to your blood glucose to kind of maintain the levels.
Okay.
They just tell the liver, that's your job. I'm just going to feed myself. That's my role. Your job as the leader is to create and feed the rest. I'm not going to do that. I am going to focus on myself.
You do you. I'm gonna do
exactly. So that's what liver. That's the difference between liver and muscle. The muscle is going to use their own glycogen to produce its own energy for its own purposes, whereas liver can have up to 400 grams of glycogen stored, and obviously, as you said, it will really depend on the person, on the genetics, and the capacity of that liver. But usually, in average, it could be about 400 grams, and that pretty much is going to be used specifically to keep the blood sugars stable. That's the main role of liver glycogen.
Gotcha. So you touched on earlier certain foods, we talked about like carbohydrates and breads, things like that, increase your blood sugar levels, right? Now, I think that people would be surprised to know that protein can also do that as well. I think that might be important to touch on too, because everybody, this is kind of where this fear of carbohydrates comes in, right? Because everybody's like, oh, insulin's bad. We don't want to raise blood sugar levels. But in reality, I do not know the name of the study, and I apologize for this, but I know that we talked about it during grad school. Bill Campbell talked about it with us, that whey protein alone showed to raise insulin levels just as much as, I think, like a piece of white bread or something like that.
Yeah, and I think that is mostly due to specific amino acids. Not all of them will be insulinogenic, but there are certain amino acids that have the capacity to stimulate insulin as well. And not just because insulin is going to, as I said before, one of the main primary roles of insulin is to regulate blood sugar levels, but another role of insulin is to increment or increase the production of muscle synthesis. So muscle protein synthesis, it will be increased by the effect of increase of insulin. So insulin is not just going to allow glucose to go in, but it's going to also allow some amino acids to sneak into the muscle within the same pathway, and allow that muscle protein synthesis to happen more effectively. So that's why it can have the role of increasing muscle protein synthesis when insulin is higher as well.
Yeah. So I think, for those of you guys that might not follow what she's saying, is that insulin is very anabolic. Insulin is, so we think of insulin as this big detriment, right? When in reality, you might be doing yourself more harm by keeping your insulin levels super low, right? Because you're not allowing all of these nutrients to get into where they need to get to. So I think the whole point that we're trying to make during this is that you should not fearmonger insulin, right? But you do need to learn how to keep it under control. Obviously, too high insulin, hyperinsulinemia, did I say it right? Can lead to a lot of negative things in the body. And I think that may be where we should start talking about, when you start getting too many carbohydrates, when you start getting an excess of insulin, what are some of the potential downfalls of that? I mean, obviously we know about increased, fat storage and putting on weight, but what are some of the other health concerns we need to worry about?
I think the main parts that I would really like to sort of focus on is that insulin resistance comes pretty much as a consequence of too much body fat. Mm-hmm. And too much body fat will come essentially from excess of consecutively eating in excessive calories on a regular basis. That is going to create a surplus that is going to, and that if it's not burned, is going to be stored as energy. And the form that we store energy is the form of fat. Mm-hmm. So that is mostly the way things can go wrong, just because too much fat storage and increasing the adipose level of the body fat can create certain amount of insulin resistance. And that can be from the production of the insulin. So it's kind of the key is a little bit damaged, or you have the wrong key. It's not going to have the exact or the perfect protein to match the receptor of the cells.
Okay.
Or the actual cell starts to have some problems in the creation of these receptors. So these receptors can be damaged, and that's where insulin resistance can go wrong, or the key is wrong. Either the lock or the key is going to be damaged.
Gotcha.
So that's my main concern. Now, when it comes to prevention and management, when it comes to prevention, we need to pretty much work on not necessarily thinking that sugar is bad or carbohydrates are going to create the problem of insulin resistance, but it's more so the management of stress, the combination of low-grade stress, chronic stress, that can obviously increase inflammation, and obviously that can combine with excess of adipose tissue, increase cytokines, that is, they are like an inflammatory marker as well. That combined can worsen and make worse that insulin resistance. So it is hard to explain whether is the chicken or the egg, who is the responsible. But from what I see is that the excessive amount of calories are going to create on a continuous basis. It's going to create an excess of body fat, and the excess of body fat with extra amount of low-grade stress can increase the inflammation, and that can consequently lead to type 2 diabetes or insulin resistance.
Right.
On the other hand, we have that if you want to prevent, you need to manage your diet basically, and make sure you're not chronically overeating, and you're managing your stress, and you're not gaining too much body fat.
Yep.
On the other hand, once you already have insulin resistance, you want to focus on quantity, quality, and frequency of carbohydrates.
Okay.
Because obviously this is more, the damage is done. So how can you mitigate or reduce the insulin secretion? Is basically to reducing or periodizing the amount of carbohydrates you eat and the quality of those. So when we think about that, we're going to look at low glycemic load of certain carbohydrates, more vegetables, and less amount of starch per meal. So you can have a dose of carbohydrates that are going to nourish you enough, giving you the energy enough, but it's not going to be an excessive amount that is going to create an stress on your body and on an excessive response of insulin to try to lower that down. I don't know if that makes sense. So we can think about preventative or as a treatment. What do we see? What is our client going through? So we can either target the prevention or help them to manage that after that.
Right. So what I'm hearing from you is that controlling calories is a big, a big deal. That is going to help prevent this insulin resistance, and also exercise. Too many people, it's not just about the calories; it's about the lack of movement as well. And you have to be working your body. You have to kind of create this environment that your body needs those calories, right? So they're not just sitting in the bloodstream. Yeah. So let me ask you, and this is kind of a curious question. Somebody that doesn't eat high carbohydrates, they're kind of on a very low carbohydrate diet, yet they eat a lot of fat. So maybe not quite keto, but more of a higher fat diet, but they're overeating. Okay, so they're low on carbohydrates, but they're still way up on calories. That'll create an insulin resistance too, right?
If they gain in body fat, that's going to lead to the same result. It doesn't matter if it's high or low carb is just an excessive amount of calories, regardless of whatever diet you're doing. So it doesn't really matter whether you're doing ketogenic diet. If you're eating too much calories, you're going to gain body fat. And if that is chronically happening, that's going to lead to the same results. So what is being shown is if you are in a hypocaloric diet and you already have insulin resistance, or you're a type 2 diabetic, you might benefit from a low carb or ketogenic diet to sort of regulate the blood sugars for a period of time, and improve the way you're using or choosing your carbohydrates. Because obviously, if you're in a lower carbohydrate diet, the only room you have for carbohydrates is the low starchy ones. So you will be only prioritizing leafy greens, vegetables that are very nutritious, very volumetric, but they have very low amount of calories,
right,
and very low amount of carbohydrates. So you indirectly you're increasing the quality of your diet, but that's the main thing that it's kind of subtle. It's a subtle change, and that's what allows you to improve your metabolic flexibility.
Gotcha.
But that hasn't been like shown that is superior, but it has helped certain individuals with metabolic syndrome or type 2 diabetic.
Yep. No, that makes sense. That's what that's why I wanted you to talk about that, because people have this just huge misconception that, carbs are bad. And honestly, people on ketogenic diets can suffer from the same concept, the same, issues that somebody that's eating way too many carbs. So this just kind of further illustrates the point that calorie control is the most important thing. Exercise is the most important thing. And then you did touch on something that was very, very interesting to me, because it's something that, I talk about a lot in my book that's coming out about my stress and about my anxiety issues in the past and all that stuff, and how stress can really, really affect the way that our body uptakes our nutrients, right? Like you said, it can help contribute to blocking the cells from taking in glucose and things like that. So, making sure that you're exercising, making sure that you're keeping calories in control, right? And that doesn't mean you can't be in a surplus, right? Because if you're trying to put on muscle, you can be in a surplus. But I think this comes to a very interesting point that I'd love to get your take on, and that is, I'll call it carb cycling, but really I just mean calorie cycling in general. How do you feel about that approach to helping kind of control this?
So when you mean calorie cycling, do you mean on a weekly basis, monthly basis? How, like in terms of the cycle?
So
like
kind of like how people will do 3 high days, 2 medium days, 2 low days, stuff like that, like during the week. Like, how do you feel about that approach as opposed to, just maybe being in a surplus for 8 weeks and then doing a week or 2 of cutting back on calories?
Well, it really depends on your approach, on your clients, and what is helping your client to adhere to the program you're giving to them. But basically, what depends as well on how you define a high day, because if you're cycling your calories but you have a weekly budget of calories, you're pretty much allocating much more calories in certain days, but you're reducing to compensate on the other day. So it's not really an excess amount that you're giving to them.
Right.
When we think about perhaps people that do cheat meals, that they can just go completely crazy on a day, that probably is a little bit different, because then you're not, I've spoken with some people that they just go, you know what, I go very, very strict throughout all my week, and I just have my Friday night cheat meal.
Right.
But they perhaps just go for one meal. So is it too bad? Maybe not. So we really need to put into the context how bad it is. If we're talking about someone who is completely sedentary, they don't exercise, they smoke, they drink alcohol, and on top of that they are having a high day or a cheat meal, then the result is probably going to be different. But if we are approaching to a person who is resistance training 4 times a week, is really active throughout the day, they don't smoke, they don't drink, but they actually have a normal dietary lifestyle as well,
right,
I wouldn't be too worried about the cycling, especially if you're accounting for the calories on a weekly basis and you're pretty much being flexible and like allocating the calories according to what your client wants to be more compliant and enjoy the process, I guess.
Yeah, no, that makes complete sense. I do have some clients that I'll use like a calorie cycling approach for, but it's more so because of like an adherence standpoint, more so than anything else. Like they just adhere to it better. But no, that's really interesting, that point of view. You know, I wasn't even going to bring this up, but you just mentioned something that was really interesting about you know, going out and drinking and alcohol. How does alcohol kind of affect insulin and maybe your insulin resistance or insulin sensitivity?
I would say more on a chronic basis, and like if you drink once a week, there's something that you don't do consistently, that's not going to harm you. We're talking about chronic alcoholics that drink a bottle a day or things like that, that obviously alcohol is perceived by the body as a toxin. It is really, really bad for your liver. And when it sees, it's just so toxic that your liver focuses just on metabolizing as fast as it can the alcohol that is in your body and tries to get rid of it before it takes up any other job within your body.
Right.
So that's why you have these headaches the next day and you feel so weak and dehydrated, because your body is so focused on detoxifying your body out of the alcohol, that's what it's going to do. So if you continuously do that, there's a point that your liver is like if your liver were fighting with the alcohol. It's like a battle.
Gotcha.
So your liver over time gets so much scarring and it's so tired that's where you get liver cirrhosis. And when you have your liver is scarred, is tired, is broken pretty much, it's a way to define it. Obviously it's not broken, but it's a way to see. It's like a military that has come from a battle. You're tired, you're scarred, you have wounds everywhere. So I see your liver like that. It's so wounded and is trying to heal itself so over and over and over that it gets to a point that it gets like a rock. Yeah. So there's no way that it's going to be able to sensitize or sense the insulin at any point. So any process that the liver does gets much more difficult to actually do it, because all your cells in the liver, or most of them, are so hardened up. Some of them are dead, and pretty much you're living with dead cells inside the same city. So that's what I want to say. It's pretty much like that's why insulin resistance would come into place, and it's just because something is not working well.
Yeah. So it's like your liver becomes calloused, and like how your hands do from a barbell, or your feet do from walking outside without any shoes on, and it doesn't allow that penetration to happen anymore. Now, so I've heard, it's not that I've heard, I've read too, but I'd be interested to get your take on it. You know, we're talking about chronic drinking and its effects on insulin and insulin sensitivity and resistance and all that. I've read studies that have shown that like up to, I think it was like 2 drinks a night for a male, 1 drink for a female, doesn't really affect muscle protein synthesis that much. But if you start getting above that, that's where we can kind of start seeing some detriments. So I guess my question is not just about alcohol's effect on insulin and insulin sensitivity in the body and everything, but if it starts to affect the muscle protein synthesis in our body, how does that affect our ability to uptake insulin and stuff.
So let me see if I understood your question.
Okay.
So you're asking how alcohol on a chronic basis or overdosing alcohol. So let's say 1 or 2 standard drinks seems to be okay.
Yeah.
But over that amount, obviously, it becomes much more than the body can handle. So as I said before, I guess what your question is, how does that affect muscle protein synthesis and recovery?
Right. And then if that affects muscle protein synthesis and recovery, what effect does that have on insulin in the body? Is there any correlation between muscle protein synthesis and insulin?
To be honest, I am not too sure, but from what I know about alcohol, it's kind of the same what I just explained, that your body is focused so much, especially your liver is focused so much on trying to get rid of the alcohol, especially if it's an excessive amount. That it's kind of everything else, muscle protein synthesis, metabolizing or synthesizing hormones or production of other proteins, it gets put on hold.
Gotcha.
So until I finish this, I'm not going to work on anything else. I have a big job to do.
So there's like a priority list.
Exactly. Yeah. So muscle protein synthesis is going to be delayed, and that's why it is not recommended for an athlete, especially if they're prepping or they are working on a hypertrophy phase, not to start drinking on a regular basis, because that's going to pretty much limit their hypertrophy gains and their recovery as well.
Right.
So what I suppose is that insulin obviously is going to have the same effect. If you're having an excessive amount of alcohol, obviously if insulin is secreted as well, if you had additional food in addition with alcohol, what insulin is going to do, because it is not going to be utilized straight away as for synthesizing glycogen in your liver or utilizing it for something else, insulin is just going to, you don't want it, you're not going to use it, I take it to my storage, and that's it. That's what happens.
Yeah.
So it is probably be more utilized and converted into fat, just because at that stage there's no room, or the one that might use some of that is busy with something else. I think
that's perfect. That's perfectly said.
Yeah.
You have a really good way of making analogies that people, I think, are going to really, really appreciate. So I'm a very visual person. So I think if I can understand it that way, I really feel like someone else is going to be able to understand it. So I really try to make this as simple as possible, because that's the way we learn and understand so much complex systems like physiology. Absolutely.
That's how I studied.
Absolutely. And, guys, if you have not been following her, please go follow her, because these simple visual graphics and stuff and these analogies that she's using, she transfers those over into Instagram, and she makes very, very good thumbnails and pictures and diagrams and stuff to help you kind of understand these complex things that we talk about, right? Because they are complex if you just read about them, right? They can be very overwhelming sometimes, all this stuff, but when you really, really take the time to break it down and to, just think of these really, really simple analogies, it really brings everything clear into picture. And when you are more clear, when you're more comfortable with an understanding of a topic, you are not going to be so fearful of it. You're going to be able to utilize it for a strength, not necessarily a weakness, right? And the more you know, not just about insulin, but muscle protein synthesis, proper nutrition, proper exercise, all these things that have to do with the body, the more successful you're going to be. So, we're going to keep bringing you these episodes, and hopefully I'll have her back on, and we'll have another topic soon in the near future. But thank you so much for coming on and talking about this. I know it's something that I'm sure a lot of people are going to get a great benefit from. And
Oh, I enjoyed it so much. I
and
really
just,
like it. Thank you so much.
you're welcome. You're welcome. And where can they find you? All that stuff. I'm going to put all the information below, but if there's anything you want to plug or anything, go for it.
Well, I have my Instagram that you already mentioned, Anti-Diet Dietitian. I have my little baby YouTube channel that is just recently launched, and I have a little bit of TikTok, so a little bit of everything. So that's basically what I have. But yeah.
The TikToks are funny, guys. Definitely go follow her. But everything will be down below. Thank you so much. I know it's going on, what, 8 o'clock at night over there?
Almost 10 p.m.
Oh, damn. I was even off. I always get the time things mixed up. But you enjoy the rest of your evening. Have a great weekend ahead. And we'll definitely be doing this soon. So thank you.
Thank you so much for having me.
You're welcome.